One of the most hottest skills is full stack development. My personal view is full stack development is a lot about understanding good backend development. I am yet to find a great balance between the roles. Usually it's, UI part which overshadows the backend, or backend overshadows the UI part or the front end part, so as to speak. Now, in my view, backend development is one of the best and most interesting career choices you can make as a young engineer. When you start in backend, you get a good solid understanding of IT systems and you get a great experience programming your way upwards and growing it into different career paths as you desire. Also, from an employment perspective, there's a great demand because most teams have more than one backend engineer compared to like DevOps, where usually a couple of teams will share one DevOps engineer, and same for UX. But if you're a backend engineer, there's usually a good demand for a small team of about 3 to 4 good backend engineers. And with the growing rate at which AI is growing, blockchain is picking back, Web3 is coming, I think backend is here to stay, and learning backend is definitely going to help you kickstart your career further. So without further ado, let's jump right into the roadmap that we have been doing. So this is part of a roadmap series. I've done a software architecture roadmap, I've done a system design roadmap. This is continuation of that, and I'm going much further down the abstraction and talking about it. So welcome to a step-by-step guide to becoming a modern backend engineer 2023, I think 2024 also. All right, let's look at this. So you start here, and internet, obviously there's some concepts that you need to be aware of. If you are now this backend engineer, expectation is doing API calls, is working on core service or microservice or a monolith kind of a setup. This is not a backend, somebody who's doing device programming and stuff like that. So internet is important. I think you should definitely get a good handle on how internet works, what is DMS, what are domain name services, because these help you in building that base knowledge base around networking. Let's move on and see. I've not checked this, so I'm gonna do it live with you guys. So once you have understood internet, select a language, and really select any language. If I was to make a recommendation, I'll definitely say JavaScript is a language which has been there for at least a decade. Python is already hot. Go is a great language. Java is an evergreen language, but usually has a steeper learning curve compared to the other two, so you can pick anything. I wouldn't recommend PHP because it's very declining side. C# if you want to get into the Microsoft side of it. First tool, version control, absolutely important. Just learn Git. I don't think you need to learn any GitHub, GitLab or Gitbucket separately. You automatically figure it out. As a bonus, in the end, I'll talk about a great course which teaches these concepts in much more detail. Now, once you have done the version control, you can understand just some general concepts, right? Like OS and general knowledge. So some terminal basics like Linux terminal basics, and you don't have to go them in order. This can be learned as you go along. Some POSIX basic, Linux terminal shell commands, a bit of shell scripting, I think helps all the job roles in technology. If you're a developer, if you're a lead, if you're an architect and so on. And then, some concepts around basic operating system. How does memory management work? How does inter-process communication work? Threads, processes, concurrency, networking, allocation of memory, deallocation of memory, garbage collection, those kind of conversations. You will automatically learn them as you grow forward in your career, so you don't have to sit and get into depth of books and talk along. Relational databases, in my view, are one of the most important skills to learn for a backend engineer. NoSQL, I don't mean NO, I mean KNOW, NoSQL as a programming language. And pick any database product that you want to talk about, right? Postgres is a great starting point. MariaDB is good. MySQL, MS SQL, Learn any database product, but the foundations of all of them are SQL language. Learning SQL and additionally learning ORMs, which is object relationship mapper, I think that's talked about here, is one of the most important concepts you will learn when you learn programming, because inherently you are interacting with databases from your code, and what the glue between them is the ORM. It kind of helps you establish the object model in your programming language and work with different relationships and maintain ACID transactions with your database. So yeah, moving from here, you can go to more about databases. Definitely ORMs first of the list. I think it's marked as a personal recommendation. Yeah, great recommendation here. Definitely understand ACID, transaction management, multi-phase commit, two-phase commit, normalization. How do you tune a query is also something which most people don't know, but I think writing good and efficient queries are very important. Not just a simple group by and order by conversations, but go more deeper, understand how to leverage partitions in databases, how to select the data, how to use the where clause effectively, understand indexes. And databases are a technology which I think you can get very easily hang at an intermediate level, which is a very good enough level for a good backend developer. Then you have a lot of different NoSQL database, tons of different kinds. I think as the time comes, you will figure them out eventually. You don't have to sit and learn document DB, because there's document, time series, real-time database, cache database, columnar database, key value database, graph databases, storage objects like blobs, stuff like that. So storage is an area in itself. And as you learn different types of programming paradigms, as you solve different problems, maybe you want to take a look at the system design conversation that I was having. So as you interact with different kind of storage, you will learn these patterns eventually automatically. Scaling databases, I don't think this is important as a core backend engineer to be able to understand how scaling of databases work, but it's a good to know conversation from at least know the indexes. Cap theorem is always good to know. These are small concepts, so you can actually know them instead of ignoring them, but you don't need to implement them at a database level. Then I think learning about APIs, tons of different conversations in API. I think 12-factor app, not mentioned here, or maybe it's mentioned somewhere else. I'll recommend. So HITIOS as a DIP principle is very, very important. And OpenAPI specs is important. Most people don't know what OpenAPI is, and it's not a good thing. Auth is very important. Learn about OAuth, JWT, different kinds of token. I think they've talked about a lot of it here. I think all are important, and I'll not want to prioritize one or the other. You can probably ignore SAML based because I don't see them getting used that often, but OpenID Connect is very, very popular these days. Learning about APIs, I think REST is natural. When you learn REST, JSON will automatically come. SOAP is ignored. I think it's not recommended right now, but I'll say that learn SOAP from a history perspective. It's almost becoming a history lesson nowadays. gRPC is picking up, and GraphQL is definitely picking up. So yeah, a lot to learn in APIs. I think there's more API design patterns are there. API security is a completely different area in itself in backend, which you can learn to focus how to do better APIs. Things like throttling, rate limiting, I can't think of, maybe session management, or if you are working with you're doing bots, like interacting with use cases like bots. These are good advanced API conversations. Moving forward, caching. Definitely understand caching happens at different level, DB level, client level, server level, CDN level. Tons of different caches available. You probably only need to know Redis because that's what is used in most of the places. I think they've talked about web security, but this is a very vast area. Here it is, API security best practices. You should definitely, there's a roadmap for it. Maybe I'll do this in the next video if there's enough demand. So please put in comments if you want to learn about API security. We'll share my understanding on API security as well. Now, by now you would have already been feeling a little boggled down as to there's so much to learn. Please don't. This is a roadmap, most likely a multi-year roadmap. I don't think it says 2023. but I don't think anybody can achieve all of this within a year. They would have to be just sitting and learning things, not implementing. So take it time. I think this if you understand the core of what these things are, this is a good couple of years worth of conversation. So web security knowledge, very very important. Definitely gain a handle on it. Hashing algorithms, probably, for example, how do you save passwords and stuff like that. So that's very very good. Testing is you don't need to get into testing as an area, but probably what is important is you do learn and do unit testing. So understanding unit testing frameworks, test management, test coverage, using tools like SonarQube and stuff like that, that's very very important. CI/CD, good to know. I think you'll eventually automatically get to know about it. Sorry, I've got a bit of cold. Then moving on, I think as you progress further, you'll automatically get into design and architecture. So till here, think of these as your early years of coding, couple of years. But as you mature as a lead, as a somebody who has understood these concepts, there's room to learn design and architecture. So then you'll get into understanding design and development patterns. So design patterns and architecture patterns are two very very different things. I cannot emphasize that on that enough. Design patterns are at a lower level of abstraction. You want to talk about design your classes, etc., like singleton and stuff like that. But when you talk about architecture patterns, you're talking of monolith, microservices. I think I just did a video. The previous video should have been talking about monolith, microservices, so on. There's new patterns emerging like serverless, service mesh, and stuff like that, which you can cover. On design, I think there's different sorts of design patterns listed here. Domain driven design is there, test driven, TDD is there. TDD is more of a practice than I think a design. It says development principle. So yeah, that's true. Moving forward from here, I think they have talked about two search engines. These are actually good tools, Elasticsearch, Solar. I think both are used in different places, so you can check about. Now as you venture more down, you'll probably see that you are getting into more architecture and design, and this is where you are typically designing for scale. What it means is you are trying to grow your software product from few functions and classes and APIs to how do you design for larger audience and stuff like that. So everything after design and architecture, I think, is targeted towards scale. Now I don't mean to say that a good code is one of the most essential parts of scale. I highly advocate that. So learning strong coding principles and writing code in a way which is very resilient and robust is foundational to all of these. Then you have message brokers, understanding messaging patterns, a little bit of talk about containerization and virtualization. Kubernetes is hot topic. Containerization, I'll highly recommend you understand it, because containerization is almost becoming the de facto standard for deployments everywhere, and Kubernetes is also again similarly almost becoming the de facto standard for deployment. So containerization and virtualization, good. GraphQL, WebSockets, server-sent events, these are more communication styles. So GraphQL is a different, like in REST you have one way of exchanging data which is stateless. GraphQL is I think sitting fundamentally at a higher level of abstraction, gives you more data, different style of interaction. Sockets are there, chatbots and stuff, such kind of scenarios where you have a live communication, open stateful sessions. Server sent events, for example, you want to send a notification, those kind of conversations are server sent events, where you have chat systems, tickers, just sending notification on social media, simple, and it's a very very well established pattern. Then you can learn about a little bit of infrastructure. I don't know why web server is here and not application server. I think you should have web server and app servers both. Nginx is most probably the common one. Apache, if you are coming from Java world, is important. I think application servers should also be paid good attention to their application server. servers, like in Python you have Django and stuff, Flask. These are frameworks that have WSGI application servers running behind the scene. Or you can have a Gunicorn or Anycorn in Python world. Tomcat is there in Java. There's multiple different application servers that you can have. I think a little bit more conversation around frameworks could happen. I don't see that. So in my view, there's a missing gap here, where we should have talked about frameworks and learning frameworks. I think that should have been part somewhere here when you are figuring out caching and stuff. But I think that's what I feel. That's a personal opinion. So here's we are at web servers, and then you go build for scale. This is instrumentation, monitoring, telemetry. This is basically observability, understanding the differences between them, and then different sorts of and concepts of observability is here, but I don't know why this is kept separate. Connected concepts, I think. Then we are talking of, I think I mentioned these when I was talking of APIs, right? So throttling, rate limiting, graceful degradation, back pressure, load shifting. These are all some mitigation strategies for when you are building for scale. So keep them in mind. And mitigation strategies are basically, how do you have a zero downtime multi-phase scenario and stuff like that. So these are probably more on the architecture side, so I wouldn't worry too much on it. But I would definitely think that this roadmap has a gap in terms of teaching frameworks, because frameworks teach the opinionated style as to how do you design your code better, how do you handle your classes better, how do you eventually determine functions, getting into more deeper conversations of REST. I think there's a room to do that, but this is a great roadmap, generally speaking. So yeah, that's all from me, guys. Thank you for listening. This was probably a long video. I don't know how long I was talking. So good luck. Please do subscribe to my channel, and if you have liked the content, please do the bell icon. Please like, share, comment in case you want to see more roadmaps in the future. Thank you. Bye bye.